Chapter 5, Section 1, Multiplying Polynomials. Right, so Chapter 5 is all about polynomials, and we're going to be working with them and doing all kinds of crazy things with them. And a lot of this stuff will actually be review. So let's get right to it. So first going to talk about something called a monomial. Okay, the prefix here, mono, that should imply one. So a monomial is just a product of a number like 3, 6, and a variable, so a letter, x or y. Okay, but here's the important bit. The exponents of the variable, okay, so not the number, the variable must be positive whole numbers. Okay, so in the previous chapter we worked with exponents that were negative and some were fractions, but we're not going to deal with that, at least not with exponents attached to a variable. So I have a bunch of terms here, and I'm just going to circle which ones are monomials. Okay, there we go, because that is 5, which is a number, and it's being multiplied by a variable x. And there is a power off that variable, it's just an invisible 1. So this is a monomial. So is this. Okay, this is just a number and times a variable, and the variable is being raised to a positive whole number. Okay, this, however, okay, is not a monomial. Okay, because if you look at the exponent attached to the variable, that is not a positive whole number. It's a positive fraction, so this is no good. This is a monomial, negative 3 times x squared. This is a monomial. Okay. Doesn't really matter what type of number this is out here. This here is not, okay, because the exponent off the variable is negative, so that's no good. And this one could be deceiving. This one is a monomial. Okay, you may think, well, why? The exponent is negative. That only has to do with the exponent off of the variable. Okay, but 4 to the minus 1, recall from the previous chapter, that's just 1 over 4. And then I have the x. Okay, so 1/4 x, that's a perfectly valid monomial. So it's just this one and this one, no. So they don't fall into the monomial family. They're perfectly valid mathematical terms, but they're just not considered monomials. Okay, what's a polynomial? Well, the prefix poly, okay, implies more than one. So a polynomial is a, if you graph it, we won't really look at those much yet, but okay. A polynomial is a smooth curve, and it is created by adding or subtracting monomials. Okay. So think of monomials as the building blocks of a polynomial and or constants. So poly implies many. Not a specific number, just many, i.e. more than one. So if I say I have a polynomial, you have no idea how many monomials there are. There could be 2, could be 3, there could be 300. We don't know. So poly is just a generic term for a bunch of monomials. Monomial, of course, the mono implies one, so one term. If you have a binomial, the bi implies 2. So here's an example of a binomial because we have 2 terms. Okay, we actually have a monomial here, and I'm subtracting another monomial. So I have 2 monomials and no constants. Okay, what do I mean by a constant? Well, you'll see that here. This is called a trinomial. Why? Because I have 3 items, 1, 2, 3, and they're just being added or subtracted from each other. So this is a monomial. This is a monomial. However, this constant, okay, this minus 7, this is not, because there's no variable attached to it. So this is 3 terms, okay, 3, hence the tri, but there are only 2 monomials, but we have 1 constant. Okay, binomials and trinomials are considered polynomials. Okay? It's just that a binomial is specific to 2 terms. A trinomial is specific to 3 terms. Polynomial could be could be anything. Well, when you're working with monomials, sometimes you have to do things to them. For example, multiplying them. So you've done this kind of stuff before, but x squared times x cubed, this is multiplying 2 monomials together. Well, the bases are the same, so I get to add the exponents. So this is just x to the 5th. Okay, pretty straightforward. X squared cubed. So this is a monomial, but it's being raised to the power of 3. In this instance, I get to multiply the exponents. So this would be x to the 6th. How about this one? Again, I have a monomial here times a monomial here. But remember, this is straight multiplication. It's multiplication here, but also the 4 and the x, those are being multiplied. The 5 and the x to the 8, those are being multiplied as well. And you should know that the order of multiplication does not matter. So what we do is we look at the numbers that are in front and we multiply those first. So 4 times 5, of course, is 20. And x to the invisible 1 times x to the 8 is just x to the 9. Done. Pretty simple. Next one. I have negative 3 halves times x cubed times 2/3 times x. This is all straight multiplication. All right. So I'm just going to multiply the numbers first. And these numbers are actually called coefficients. Some terminology for you. All right. So I'm actually going to put them side by side so you can see what I'm doing. Just going to itemize them. You don't normally have to show all this work, but it's just so it's clear. This is negative 3 halves times 2/3 times x cubed. It's a pretty rotten looking cube. I think I can make that. That's better. Times x. Okay. So let's just multiply these together. A negative times a positive, of course, is negative. Okay. And 3/2 times 2/3. Yes, you can multiply top times top, bottom times bottom, and then reduce, but I would argue it's kind of a waste of time because I get a simplification. 3/3, that's just 1/1. Same with 2/2. That's just 1/1. Well, how about that? I just have a negative 1. Okay, times x cubed times x to the 1 is just x to the 4. Now, though this answer is correct, normally we wouldn't write a monomial like this. If you ever have a 1 or a negative 1 in this case, we don't bother with the 1. So I'll just say negative x to the 4th. Okay? So that's what I get when I multiply these 2 monomials together. Next one. Okay, the next one we have a little bit more going on. I have a monomial here times, I have a monomial in brackets, but this monomial is being raised to the power of 2. Okay, now remember from BEDMAS, before I can complete this multiplication, exponents must come first. Okay, so this 2 is affecting only what's inside these brackets. So that has to be dealt with first. So this x cubed, not going to do a thing with it. It's going to stay put. All right. But remember, negative 2 all squared, that's just negative 2 times negative 2, which is positive 4. And then I square the x. That just becomes x squared. Okay. Now that the brackets are gone, now I can complete the multiplication. So there's an invisible 1 here, so I just get 4. And I add the exponents, so this is 4x to the 5th. Okay. Not too difficult. All right, next one. Similar to the previous one, I have a product, but this 6x is being squared, so I must complete that first. So that's 36x squared times 1/12 x to the 4th. Okay. Now, hopefully, you can actually multiply 36 times 1/12 in your head because that's exactly the same thing as 36 divided by 12. And you should know your times tables. That is 3 and x squared times x to the 4th. I get x to the 6th. Okay. But just to show you that little part down here, why I got the number 3. So this is 36 times 1 over 12. Remember, there's an invisible 1 under here if it helps. Okay, so I would get 36 over 12 when I do the multiplication, but reducing these, of course, I get 3 over 1. So 3 over 1 is just 3. Hence why I have that. Moving on, it says expand. Well, really we're just being asked to apply what's called the distributive law. My teacher called it the rainbow rule because early on it would help me to draw these little arrows and it kind of looked like a rainbow, hence rainbow rule. So this 3, okay, is multiplying this set of brackets, everything inside it. Okay? So you can almost think of this x plus 7. Think of the brackets like a basket. And inside this basket, you're holding a bunch of stuff. And then when you multiply the entire basket by 3, what you're doing is you're tripling each item inside. So you're multiplying the x by 3, which is 3x. And I have a positive 7, and I'm multiplying that by 3, which is positive 21. Okay. Hopefully that should be review for you. Next one. I have negative 2 times, and this here is a trinomial. You don't have to put these arrows in here. Eventually you won't, but it doesn't hurt. So just multiply everything in here by negative 2. Just be careful with your signs. So that gives me negative 2x squared. This would give me negative 10x. Negative 2 times negative 1. Remember, the sign in front of the number is part of the number. Plus 2. And there we are. Next one. Oh boy. Okay. So I got a bit more going on here. But let's just deal with the numbers first and then the variables. So 2 times 3 is 6. And then x squared times x squared, that's x to the 4th. Wasn't so bad. Then the next one. This is a positive. This is a negative. So I know this next term is going to have a minus. So now I don't have to worry about the sign anymore. So 2 times 5 is 10. And this gives me x cubed. And the y is still there. And there we go. Next one. Ooh. Got to be careful. Okay. I have distributive law going here, but I have it here as well. But then I'm subtracting. Okay. Well, remember your order of operations. The multiplication has to be done first. So these get multiplied first. And these get multiplied first. Okay. So 2 times x is 2x. 2 times positive 4 is positive 8. Moving on. Now, this is not 5. Think of this as negative 5. So negative 5 times x is negative 5x. Negative 5 times negative 9 is positive 45. Right. Well, we're not quite done, but at least the majority of the work, the hard part, is over. Now, we just simplify as much as possible by combining like terms. So I have 2x and a negative 5x. Combining those together gives me negative 3x. Okay, I'll just change the color here. Here I have plus 8 plus 45. Okay, I'll put those together. I get plus 53. And we're done.